So let's continue our discussion on plotting. Plotting is extremely important because no matter what you do, unless you communicate what you do to your coworkers or anybody else around there, it doesn't matter. It cannot be whatever you're working on cannot be implemented, cannot be followed upon. So communicating your results is very important, or whatever it is that you're working on, and unfortunately cannot always be done in words. And we know that saying picture is worth 1,000 words. It is always correct. So whenever you have data that you want to present, the best way to do it is to present a plot. You have noticed in your homework you had like a file with like a large number of data. As humans, we can kind of grasp data that is given as a table if there is, well, up to 10 lines that we are processing. Beyond that, it becomes difficult, really difficult to eyeball what the data is, and if you're supposed to make a decision, you can always make a decision first time around. You can actually guess a decision and just go with it. Okay? But if you want to, in your career, make consistent decisions that are actually based on the data you see, you need to be able to compare. And plotting graphs of data really enables you to compare and then make those decisions in an educated way as opposed to just guessing. So plotting the data is really important. Okay. So we had actually a plot that we were working on, and I'm going to actually redo it. So I'm going to create x as a linear space 0, 3. And let's see, Carter. Is Carter here? Carter, can you tell me what is this going to do?
It's going to create a bunch of columns between numbers 0 and 3.
So a bunch of numbers. If I don't specify how many, what's the default? Do you remember?
Is it 100?
100. Do you want to change that? Do you want to? No? 100 is fine? Okay, I'm going to put 100 just to remember that there is 100 of them in there. So that is my x. Okay, so this is a bunch of columns. That's actually a row vector is called a bunch of columns. And you can actually see it appear here in the workspace. I have 1 by 100. Double refers to the type of data. This is floating point data in double precision. We'll get to that later. All right, and then I'm going to create y1. And here I am. I did not do diary. So today is 10th already. Wow. And I'm going to repeat this. Okay. And I'm going to say y1 is 10 times exponential function of minus 2x. y2 is 12. What I'm doing, again, if you do upper arrow, then it's going to recall what you did last time. So with upper arrow, you can get what you typed in before. And I did that already on Monday, so I have that. So I have now data x and y. It's hard to look at 100 numbers, are hard to look at, and I want to plot y1 versus x and y2 versus x, and I want to compare the two. And there's a way, since actually I use that exponential function, okay? Data is growing exponentially, so I'm going to see much more if I plot y data as log of y data. Because then instead of having 10, 100, 1,000, I'm going to have 1, 2, 3, right? Because it's 10 to the 1, 10 to the 2, 10 to the 3. So whenever you're actually looking at data that spans number of orders of magnitude, this growing by 10 is called order of magnitude difference, multiple orders of magnitude difference. That's when you want to actually present data on log scale, okay? Or at least that part of the data that is growing like that on log scale. If you have a reservoir where your permeability is going over multiple orders of magnitude, you're in trouble, okay? You're in carbonates probably. But to actually see the differences between the data, it is very good to use log scale. So the way you do that in MATLAB, you say semi-log y. That basically means Semi is half, so do half of the plot in log scale and use that for y. So basically you can do xy1, and I'm going to do it in red, xy2, and that one is going to be blue solid line. So when I plot that, the plot pops up, and the plot has hard time figuring out my screen today. If I do new figure, maybe that helps. Okay. That still doesn't help. Wow. Okay. I'm going to briefly exit the MATLAB and try this again. Maybe it improves. This is a problem between the screen or showing things on the channeling that figure to that screen. And then MATLAB. Okay. That's better. Okay. When you don't know what to do, reset. So I closed the MATLAB and opened it back again. Okay, so I got my two plots. And again, I know now what I plot, yes.
So semi-log is because only one of them, or like half of it, is on the log scale. How do you, is there any way you could change it? Like if x was y, y was x?
So,
or just semi-log x?
The moment it's like semi-log y, then you know that there is a function called semi-log x.
Okay.
So you can do it.
Semi-log would just do both.
Yeah. Semi-log would do both. Yes. Okay. So if you're thinking it's logical, it's probably implemented that way. Or there is a way, so there is a lot implemented in MATLAB, so probably the solution exists somewhere. Okay? So semi-log y, x and y, and this is something we'll get to programming. This is something that you would be able to do as well yourself. If you just went through the data and plotted log of, you know how to take log of something, right? So it's not all that difficult to produce yourself. And then you can see the data is going here. It's 10 to the minus 3, 10 to the minus 2, and so forth. Okay. All right, so let's annotate the grid a little more. I'm going to do what I like doing and what I need to do. Oh, wait, we had some promises from last time, but I forgot what the promises were. Somebody was supposed to research here. I'm forgetting what though. And I don't have the video anymore.
I did it during class, and I figured out during class, forgetting what it was.
Great. Okay, since we're all forgetful and we don't have the video, then we're gonna skip and move forward. I was supposed to figure out how to get this as a preference so that it always uses font size 16, because that's what I have the rest set up, so you can see that I use very large fonts for projecting. All right, so this basically sends font size on the axis. GCA refers to the current figure axis. It sets the font size to something larger so you can actually all see. Now let's actually annotate this plot. I can put the grid on, and grid actually tells me that I'm on log scale, right, because it's not spaced equally. So some common things that you always want to do, you want to put the legend, so you want to know what is the red plot plotting, what is the blue plot plotting. Okay? If you're in any shape or form scientific or quantitative, you should put here what this data is and also what units you're in. Okay? So if it's permeability, it could be meter square, it could be Darcy, it could be micro Darcy. There are some units, right? And you need to put them on the plot. Here we just kind of plotted the data, so I'm going to label it as x and y because right now it doesn't mean much, but I can move on to or I can come up with the labels. I can think of it as temperature. So grid on. Second thing that I like to sometimes plot is maybe you want to, for whatever reason, show only parts of this plot. For instance, for x between 0 and 1.5, and for y between certain other two values, because you want to zoom in. So you can be able, you can actually tell MATLAB how to do that too. So for instance, x label, I think actually I have some, I'm getting ahead of myself and I have suggestions on the next slide. So for instance, axis will set first the axis limits. And the legend, oh okay, so my suggestion here was Monday and Wednesday. And then, oh, temperature, sure, why not? Let's call this temperature, and you can set the font size, though I already set the font size outside, so this will not really take an effect because it's already in place. And label, apparently somebody imagined that this numbers we came up are time and temperature. I don't know that temperature is ever exponentially changing, but okay, sure. Maybe it is in some very fast cooling that could be exponential. I'm going to come up with some physics beyond. So then you should actually get something like this. So let's do that. So axis between 0 and 2.5, and this is 10 to the minus 3 and 50. So these limits are, these are basically x limits, lower and upper limit, and then lower and upper limit for y-axis. Okay? If you had 3 axes, you would just continue. So you could actually have a 3D plot. Then I'm going to do a legend, and suggestion here is that these are temperatures that are Monday and Wednesday temperatures. And there is position. So let's see what happens if I don't put the position. This is not, is this the plot? No. This is the plot. So default position is here. So if I don't do a position, there will be a default. Or I can actually, set comma 2. Apparently that did not take, so I'm going to delete this first. Oh, so position 2 is actually this one. Is there a position 3? No, that doesn't take say. So help legend. Legend doesn't seem to be doing. What I asked it to do. So since probably this is the latest or probably last 2 editions of MATLAB, they changed from numbers to north, south, east, west. So that number 2 was simply ignored. So legend, I'm going to delete it. So you can also click on things. I can click and drag. Let's just be clear about that. So I'm clicking with my mouse and dragging it along. But I often want to set things from the command line so I can have them. Okay. So I need to specify location. Okay, things have changed from when I wrote this slide. I'm still not seeing. Okay, I'm gonna figure this out outside of the class. It might be that I need to return the angle. So location, I'm gonna get back to you on how to set the location. Oh yeah, it did. It actually corrected it. All right, location is south. Why didn't I see that immediately? So basically south is where south would be, right? North, south, east, west, or you can just leave without any. If I leave without anything, then it's gonna simply put it in this corner. And I can always move it around as I need to. Okay? And then let's put some labels. I'm gonna say temperature or time in seconds for X label and font size 12. Let's see if that's gonna actually take effect. Yes, so it's actually relatively small. So if I want to put something larger, I can put some larger font. And that changes here. So that is X label, and Y label is temperature in Celsius degrees, though I don't think this data is any close to. I'm not gonna set the font size. So that is my temperature in Celsius over there. So those are the basic things that you need to put. If you want a title, you can, but basically from having a legend, having labels on X and Y, you should already know what the title is. But I can say title, temperature, comparison. There we go. And I should know. Typing today is, for some reason, challenging. There we go. All right, so this is a nicely annotated scientific plot. Did everybody have a chance to produce this? All right. So let's move on. Yes.
The font size can be set in preferences.
Yes, but that's, and then I already have it set for figures though. Okay.
That's great.
Because I have it already set for the main MATLAB, and that's already large font size. So I'm gonna follow up after the class. So I want that font size so I don't have to. But granted, if I constantly type in set GCA to font size, you will remember that command, which there's a benefit to that.
It's not under fonts, it's under figure copy.
Oh, got it. So I'll actually go and do that while you work on this assignment. Okay. So you will create 100 points XY that are on circle radius 1, and you will plot that circle in red color, so using a solid line. And you will also find how to change the line width to 2 thicker lines. So when you are presenting plots, especially in PowerPoints, thicker lines are better. So for this, you will need to remember how to parameterize a circle and create these 100 points X and Y. Sine and cosine function are SIN and COS, just in case you need to use those to create points on circle. You can work in pairs if you'd like. Consult. And meanwhile, I'll set my preferences. No, still small. Let's see. There's apply to figure. There's a bigger copy. Yeah, I'll play with it later. Do we remember how to parameterize the circle? And use that to create 100 points? No? Yes, no? Points on a circle are x of t, let's say, is cosine t. Y of t is sine of t. Yes? That's how do I parameterize a circle or radius 1? If I had another radius, I would put the radius here, radius times. Are these 2 points, like for any t, are these 2 on a circle? How do I check? What is x squared plus y squared? Cosine squared of whatever t plus sine squared whatever t is always 1, right? So these are points on a circle. And I need 100 of them. How am I going to execute that in MATLAB? MATLAB doesn't plot functions. MATLAB plots points. You have to figure out what the points are and plot them. Okay. So how will I get 100 points x and y that are on the circle? Need to pick myself. Yes? For instance, yes. So I'm going to do t, or if you want to call that theta, the angle, right? T, which is length space between 0 and 2 pi. So these are my angles. And length space by default will give me 100 points. So I'm good. Okay? So that's my t. I can plot first 10 just to see what they are, right? How do I create x and y? It actually works. Why? Because MATLAB will process the entire vector t and give me cosines of every value, right? And for every corresponding value, I can also create sine of t. I'm almost done. Now I just need to plot these points. Do I need to plot t? What will I plot? X and y, just x and y in a plane, right? So parameter I don't need to plot. I just use the parameter to actually create my plots, points. So I'm gonna go with a new, I'm gonna clear all of the previous figures. Oops, now I just cleared everything, okay. I wanted to close all, really. So t, good news is coding and coding, it's easy to repeat. If you have it, you just cut, copy, paste, and execute again. So these are my values. And what was the, how will I get red line? That works. All right. There are things about this that I don't like, as usual, font size. Okay. this circle looks a little squished. So I'm going to say axis equal to actually make it equal. And I want actually tight lines around it, so I'm going to say axis tight. So this is just beautifying my plot. So that is it as far as the plot, and there's that line width business. If I don't know, if you don't have somebody to tell you how to set the line width, what's the first approach? I want this plot to actually have a thicker line, but I don't know how to set it. Yes?
Maybe instead of font size.
Try to set the line width.
Yeah.
Let's try, I don't know. GCA, those are axes though, but let's see. Well, that worked, but for the axes. Okay, so GCA is the axis. But what if I wanted to do help on something? Which function would be a logical one to do help on? Plot. So go to plot and see whether in that list of things. So you do help plot. So this is sort of approach, how do you help yourself? So first you try something. This was a great try. It just worked for axes. It didn't work for the plot itself. Oh, and here's an example actually that just showed up with some modification. So you could actually, in plot itself, you could set line width. You could also do marker edge color if you have marker. We didn't ask for points to be anything, but we could have. Marker face color and so forth. So there are suggestions here, and actually if you go, so it so happened that this example had immediately a suggestion, but if it didn't, then you look through all of the possibilities in here that are suggested. Okay. So I'm gonna replot, and I'm gonna say line width two.
Is there any way to do that without having to replot it?
Hmm?
Is there any way to just like say like set line width to?
There is. You would have to get a handle which we didn't get during the plot. Okay. So there is something called handles. That is basically the address of the object. So actually you can return, so all of these plot functions return a handle. So I believe you can call it H. And now you can set properties of H. So you can actually, I think now, say set H line width, oops, that's 4, okay? So basically, if I don't return the address, I lose the address. It's plot and it's there. There are certain objects that always have, like axis always has the address and it's called GCA. I don't need to return it. Okay. But now I can actually modify H if I remember. And speaking of the axis. Alright. And all that axis tight, axis equal. Alright, so this is my circle already. So again, remember, underneath this line it looks continuous, but underneath the line are actually points X and Y. So I plotted 100 points and it looks beautiful like a circle, like as if it was an analytical solution. Okay? But it's not. The computer is actually plotting actual points. And in order to plot anything, you actually have to have the data, you have to have the plot, the points.
Could you repeat again what axis type and what axis equal?
Tight basically tightens the axis around the object that is plot. Okay, so my axis is not going wider than the circle itself. And equal means equal proportion. Do it proportional. Because the way it initially plotted, even though I had 0 to 1 here, 0 to 1 there, I had kind of squished circle. It didn't look like a circle, it was like ellipsis.
Right.
So it wasn't. So it's some sort of default setting.
Okay.
Because again, MATLAB doesn't know that you're plotting that these x and y axes have the same meaning and same length. In our case, they do.
Okay.
So if you want to enforce that, then you say axis equal. And again, if you do help axis, there's all kinds of little other things that you could set. We were already setting axis. Well, in this one way to tighten it would be to type this minus 1, 1. So minimum and maximum that you want, but that we kind of already have. Okay? All right. All right. Often you want to actually compare things, different things. So you might want to have multiple plots. So let's do this exercise. This exercise is doing nothing more than really just, we're still working with linspace 0 to 2 pi. You can actually use t that we just had. And we're plotting sine x function, sine 2x function, sine 3x function, and sine 4x function. Okay? So that's all we're plotting, but we're plotting it as 4 plots shown together. So we will show these plots as, we're going to tell MATLAB, you will create a grid of 2 by 2 plots. And in first location, put sine x function. In second location, put sine 2x function. Third and fourth. And the result should look like this. Okay? So that's just creating 4 independent plots and putting them together. So let's give that a shot. All the other modification other than plotting x and the function itself is for beauty purposes, I'm setting axes to be relatively tight so that they're all shown the same. And I'm giving each plot a title. I'm gonna work parallel with you. So I already had t as a linspace between 0 and 2 pi. That's just fine. So I'm going to say subplot 2, 2, 1. I'm using axis incorrectly. I'm not sure what is the problem with the axis. I'm gonna plot first. Oh. I think the problem was that I had a plot open and things went to that plot. Yeah, so now it's fine. Okay. And I'm going to give it a title. Now I'm going to continue in the second location, plot sine 2x or 2t. I'm using t because we already had a t variable. Okay. And then subplot third location. You can see the moment I say subplot, it's placing the plots. If you noticed, as long as you put semicolon, you can pile up multiple commands in one line. And then final plot. We will now briefly introduce scripting. So what if I wanted to save this for next time and I want to execute it on Friday? Okay. To save myself, I'm going to say new script. And that new script opens here. So I'm actually just pretty much going to copy all of these commands into that script. Okay. Now, for the next time, okay, this script might not, t might not exist as a variable in the system, so I'm going to add my t as well. And since I encountered that problem with actually things being sent to my old figure, I'm going to create figure just creates a new fresh figure to avoid any issues. Okay. So this is now a script that I can re-execute if I actually save it. So I'm going to say save as, and I'm going to say plot sine functions. Or plot sine is enough. So this is now a sequence of commands. It's going to have .m. If you open a script here in MATLAB, it's going to save it as a .m. And .m indicates it's this script. It's a script. And you can see that it showed up right here as plot sine in my folder. So I'm going to actually close this plot. And I'm just going to re-execute it, plot sine. And I can do it all over and all over again. Fix as many things as I wanted to fix. For instance, oh, I really don't like that it goes from minus 1.5 to 1.5. I want to change that. Well, I'm going to change it in the script. And one more. Is that it? One more. So I'm going to change all of the axes to go between -1 and 1. I'm going to save that and re-execute again, and now it's tighter. I We're not wasting any empty space up and down. So you can see immediately, oh, I wanted to change something. I briefly change it and re-execute it. It saves a lot of time, and that's the whole point of computation. You want to save these scripts, what you've been doing. A, so you can know what you did once you go back to it. And B, so you can change it, modify it, use it. You will go to another class, you'll be like, oh, what was that subplotting thing again? You can go to your notes, of course, but if you also already have a saved script, the script is your starting point for plotting whatever else. Okay? So here, basically, here is that you have subplot and then you plot something and you keep moving. So you just change what you're plotting and you can use it differently. Okay? Everybody had a chance to do this? So save a script so you can actually have a script for later. All right, so this is the result. Now you already in your homework 1, there was that example for 3D plots. Okay? So just like in 2D plots, when you're plotting something in 3 dimensions, you need to know points to plot. You need to know x, y, and z of every point that you want to plot. And what you did in that homework without necessarily knowing what you did, okay? You created x and y mesh grid. And that's a grid of points between -2 and 2 in both x and y. And then you created z as x. We actually know what dot means. Okay? Dot will actually go, so if these are vectors or matrices, dot will actually go and execute this. What is it? It's x times e to the -x squared plus -y squared. It's going to execute that for every element of the matrix. And then you can do the surface. So let's actually, I'm going to sort of tear this apart so you understand what the meaning is. But the whole point of this entire exercise is creating on this surface here that is plot, all of these points at the corners. Okay? Those points are actually the points we're plotting. These little patches in between are just linear patches in between. Okay? We are actually creating these points and plotting them as part of this exercise, and then the MATLAB will kind of create a surface in between, but basically it's just doing little planes in between. Okay? So you have to, every time you're using a 3D plot, you actually have to come up with points x, y, and z to plot. So let's analyze that a little further. So this is the function. Function could be anything. It could be, for instance, 2 minus x squared minus y squared. We had the different example before. So the plot or the functions that you would be using in MATLAB are mesh, mesh c, surf, surf c, and surf 1. We will exemplify first surf. Okay. And the way they work is that you could either have z, just z data. So those are some elevation. Let's say that we're calling that elevation, z. And then, since it doesn't have x and y for that z data, MATLAB will simply come up with values. Okay? So it will put for x and y, it will put points between 1 and number of the points on each axis. Okay? So let's actually try to create any matrix. I'm going to say A is random between, and I'm going to give myself 20 points. So this is a, I could technically do surf A, and I'm going to understand these values between 0 and 1 as elevation. It's going to look ugly. Okay, I'm going to close. Okay, looks ugly, but that's what my random points are. Okay. I can rotate it a little. Okay. So this is the top view. Top view is not that bad. Okay. I can, oh, well, what are these colors? What do they mean? Well, I can just say color map. Oh, color bar. And then it should, okay, so values close to 1 are blue. Values close to yellow are close to 1. Okay? But when I plot them as elevation, they're in between 0 and 1. So you rotate. If you click on this, you can rotate. Well, and these are my random points. It's not a pretty surface. Now my points on x and y axis are going between 1 and 20 because MATLAB didn't know what corresponding values are. Okay? So what MATLAB really plot here, it plot point 1, 1, and a of 1, 1. Okay? Then 1, 2, a of 1, 2 elevation, right? Then 1, 3, a of 1, 3, and so forth. And it just connected them with planes. So this point here is 2, 4. So 2, 4 is an x and y values, right? X, y. 2, 4, a of 2, 4. Okay? That's what MATLAB plots. So it needs x, y, and elevation z to actually plot the surface. And that mesh grid actually comes up with that. So what does mesh grid come up with? So there was that x, y. I'm going to go back to, I don't know what the suggestion was. Minus 2.2, oops, 2. I'm going to give them a little smaller. I'm going to give them a 0.5 so we have less points so we can see things better. So you can see that x is 9 by 9. So it's a matrix. And y is 9 by 9 as well. And the values in that matrix y are going between minus 2 and 2, and they're spaced out. And each row is just a repeated value. So I start with minus 2s, then minus 1.5, minus 1, and so forth. In x, I have the same thing, just things happen by column. So my first column is minus 2 and so forth. Here I'm actually seeing columns 6 through 9. And they're 0.5, 1, 1.5, and 2. So when I combine for each position, x and y, I'm going to have precisely points on all of that grid, x and y combinations. Okay. So x and y mesh grid will give me two matrices. One of them will have x coordinates of all of that mesh that I have, in 2 dimensions. And y will have y coordinates of the same thing. And now I just need to produce myself z's as a function. Okay? And my z, I can take any suggestions. So here z was taken as x dot So what this will create for every position, and I have 9 by 9 positions, it's going to take x value at that position and y value of that position and compute x times exponential of minus x squared minus y squared and place that in the corresponding position in z. And these dots here are ensuring that it's really happening position by position. Does that make sense? So I get my 9 by 9. And now I can actually plot those x, y, and z in all positions, have actually points. And I just need to find my figure somewhere. And now I get that prettier figure. It's not random values anymore. I actually computed the function, which is when I write it down, it's x e to the minus x squared minus y squared. Does that make sense? So the key problem here was finding these x and y positions for which to compute, right? And I need to put them in a matrix because I have a matrix of points. So those are the points here. So for each of these points, my x returned by mesh grid has an x coordinate of these points, and y has y coordinate of those points, and z is the corresponding z coordinate that I just computed, and then I can plot it with circle. The rest, whether I'm gonna do mesh, so I can actually do a mesh. So this is just now types of plots. I can have a wireline plot. Okay. Mesh C will give me contours below that are colored the same way as data. Surf C is going to do the same. Okay. So I'm going to get contours of the data below. So those are all of the pretty ways that you can actually present your three-dimensional data. All right. And I went a little over time. I apologize.